Now, classifying and securing data. This is going to be a sequence of videos where we're going to be focusing more on policies and procedures. And before you roll your eyes, keep in mind that these are still as important as technical controls whenever you need to prove compliance and whenever you need to cooperate and to work with external parties, with business partners, even with... so it might not be the most spectacular topic in this training, but I'll try to make it sweet and easy to follow and a bit fun now and then. Now, when talking about security in general, we've covered this in the first videos, and we introduced the concept of the CIA triad: confidentiality, integrity, and availability, and we understood that we need to ensure that we protect all these three in order to have a coherent implementation of security. Now, we also have to take into consideration situations where not all of these pillars apply to any type of data. So, for example, if you're thinking about some data that is supposed to be publicly available on a website, that should be publicly accessible by your clients, your customer, or by anyone for that matter, then confidentiality of that data is something that doesn't warrant any concerns. And while everybody can agree that security is important, privacy is also important as well, or privacy if you wish. I'm going to leave it as privacy. Privacy is a governance requirement, especially when processing personal data or personally identifiable data. Data that can be used in some way to uniquely identify a person, their attributes, their financial information, maybe their health status, and all that information and the way it is processed, the way it is stored, who has access to it, when should it be disseminated, for how long should it be stored, all these factors are going to be accumulated in something called a privacy policy. So while security is about, confidentiality, integrity, and availability, privacy is more about the regulations that apply to the proper use of that specific type of data. And since we're going into the regulatory and legal realm here, as usual, there's going to be a lot of blame to go around. So let's see exactly who it is to blame for which task when involved in protecting data. And we're going to start with the data owner. The data owner is the sole responsible for ensuring the confidentiality, the integrity, and the availability of that data. It might be the person who actually created the data, or it might be the person that introduced the data in your company or in your system. Nevertheless, they are responsible for securing that data. They're also responsible for classifying it. That is, if you are the first person who ever introduced that piece of data, it doesn't matter if you created it or not, but you are the first responsible for letting everyone else know what that data is about and how sensitive it is, what type of information is in there, and then according to that classification, everybody else is going to know how to treat that data, how long to store it, where to store it, and how to secure it better. As part of the labeling process, the owner also gets to decide who should have access to that data from the very beginning. And we're not just talking here about individual people, but of course an organization can be the owner of that data, especially with intellectual property. That's when an organization holds the intellectual property rights of any data that is generated within its perimeter. Now, a data owner usually chooses some additional minions or acolytes to help them in managing that data, and those are data stewards and data custodians. By definition, the steward is the person responsible with data quality. That is making sure that the data is properly labeled, handled, it is stored and represented in a manner adequate to the contents of that specific data. The custodian, on the other hand, is more of a technical person, especially with digital data, and that person is responsible for ensuring the well-being of the system that hosts that data. That is the storage appliance, making sure that the data is properly encrypted, making sure that the backups are being performed regularly, and also that the backups are secured as well as the original data. And it also manages any type of access control that might be implemented in order to provide or to deny access to that data. The privacy officer is the person that is more on the legal side, that has some sort of a high-level overview in which they are able to determine whether the specific type of data that we're processing, that we're storing, complies with the local and global regulations. The data controller, a lot of job roles in here, right? Data controller is the person responsible for making sure that the data is not used outside of its intended purpose, and is also not used outside of the allowed regulations. So in other words, if we're collecting the client's email addresses, make sure that those email addresses are only used as, let's say, unique identifiers or as a correspondence address whenever we need to reach that customer, not for sending spam or for sending them to the highest bidder. And finally, we have a data processor, and that is the person or the entity that takes care from a technical perspective and makes sure that the data is properly collected, stored, and processed internally. Data classification is a very important process so that everybody knows what to do with the data and how to process it and how much care it should be applied to that data. Now, most classification methods are going to rely on some sort of confidentiality requirement. So you're going to see classifications such as, public, confidential, or critical, which might be mapped to something such as unclassified or secret or top secret, depending on which spy movies you're watching. And usually these categories are pretty self-explanatory, with the confidential or secret category usually being a situation in which the data can be accessed by only those who are approved to do so. And that is people who have signed an NDA, maybe business partners. Somebody has to give them access in order to access that data. At the other two ends, we have the public information, which normally doesn't have any kind of confidentiality requirements. And we have critical or top secret requirements, which means that it's on a need-to-know basis, and very few people have access to that data in order to keep a tight control over the potential risk of data exposure. We can also classify data by its actual type. So for example, if the data contains some sort of proprietary information, that is intellectual property, for example, then the data belongs to that company only. Of course, this could be a target for data breaches. Competitors or somebody who doesn't agree with the business practices of a specific company might target this data and try to make it public in order to hurt the public image and perhaps even the entire business. You can also have private or personal information that uniquely identifies a person. Of course, this can also be the target of a data breach because information that pertains to individuals can be used in identity theft. And in general, sensitive information is information about a person that is not necessarily used to uniquely identify that person, but if that information is disclosed, becomes public knowledge, that person is not going to be happy about it. So it could hurt that person because it might be about their political affiliation, religious, sexual orientation, maybe their financial habits or their income or their health status. An official classification of data types starts with data that usually has the most concerns attached to it whenever we need to process it and store it, and that is personally identifiable information, PII. That's information that can uniquely identify a person. This also has to be taken into a specific context. So for example, if something such as a government assigned identity number or a social security number can definitely be a personally identifiable information, other things such as the IP address that the user is using to browse the internet in specific context can also be used to identify that person. This information is sensitive because it first can be used in identity theft, and also sometimes knowing enough about a specific person is enough for you to bypass their, let's say, password reset mechanisms. If they have a password reset mechanism that relies on security questions that only they should know, well, if you know that information, if you know about that person, if you know enough about that person, then you might be able to bypass those security questions. Customer data in the context of a company, it might be about sales data, it might be about a customer's profile, their previous purchases, their business agreements that we might have with them. In general, it's not considered as sensitive as other types of information, but especially in a business environment, we usually provide access to this type of information only after we sign an NDA. That's a non-disclosure agreement document. Health data, health information, pertains to the health status of a person. It might be their health history, it might be whatever they're suffering from, whatever treatment they might be on. That's information that shouldn't become public knowledge. It can be used in blackmail scenarios to create some serious damage to a person's reputation. In finance-related data, This one covers data that pertains to how much money you have, what income sources you might have. Of course, probably you don't want everybody else to know this, but it also covers credit card information as well. Now, we also have specific standards that take care of the way credit card information is processed, is stored, how transactions are conducted, and that standard is called PCI DSS, which stands for Payment Card Industry Data Security Standard. Other concepts here related to data that you should know about are purpose limitation. This is the purpose for which the data is collected and used for. And you have to make sure that the data is not going to be abused. It's not collected for other purposes and it's not stored more than required. An impact assessment is also connected to sensitive data because, especially for companies that process a large volume of personally identifiable information, health information, financial data, they need to periodically perform this type of an assessment in order to mitigate any potential risk for data breaches that could affect those sensitive sets of data. Data retention is strictly related to compliance because in many cases, in many countries, according to the local legislation, you might be required to store a specific type of data for either a minimum amount of time or for a maximum amount of time, especially if that data is really sensitive. Don't forget, from a technical perspective, that this long-term retention should also be performed on storage equipment and with storage solutions that are just as secure as the data that you're using on a daily basis. Data sovereignty is an issue that comes into play whenever you're thinking, where should we store our data? And who has jurisdiction over that data? This is extremely relevant, especially when you choose to store that data in a cloud environment. And it's not just your day-to-day data. You might be choosing to use a third-party backup provider, for example. Well, that data still falls under the same jurisdiction and has to comply with the same regulations as your normal data. And since we talked about where we are storing that data, it's actually a problem that can be approached from two different angles. First of all, where do you store your data? So choose the appropriate data centers, choose the appropriate cloud regions. And also think about where are your users located, because if your users are accessing that data from outside an approved jurisdiction or legal area, then you're going to have a problem in there. Hence, all the web services that you might encounter over time that say that this service is not yet available in your region. Even though the data is there, but you are not located in a country or in a location where you can access that service. Now, this probably doesn't come as a surprise to anyone, but the downsides of a data breach are actually many. So, in case your confidential data, your sensitive data becomes public knowledge, that's what we call a data breach. And the effects of this are going to be felt first and foremost on your reputation. Because if you're a company that was supposed to process confidential data, that you had some customers that they trusted you with their data, and you had a data breach, that's obviously going to be a really bad mark on your scorecard for any future business that you might be willing to do. People need to trust you in order to provide you with their data, with their money, with their secret information, with their files, with the whatever you're choosing to offer them. Other than that, of course, the actual data loss that's happening could also be damaging for your business and of course your reputation, especially if you're a software company that develops a proprietary product. If your source code gets stolen, well, of course, that's going to be very bad news for any future business that you might be willing to do. Identity fraud can also be encountered, especially as part of a data breach that targets personally identifiable information. And in some countries and in some regions of the world, the simple act of suffering a breach, which after an investigation is determined that you did not take a minimum amount of measures to prevent it, you didn't perform any due diligence tasks in order to minimize as much as possible the risk of a data breach, can also attract some huge fines. A GDPR in Europe is one of these examples where you might be fined for not doing your homework. Now, everybody can suffer a data breach, so don't get me wrong, you're not being punished for having a data breach, you're punished for not doing the minimum effort in order to prevent it. If you don't lock your door when you go out, then the insurance company is probably not going to be willing to pay in case you have a home invasion. Also, in some regions, depending on the local legislation, some companies have to notice their customers whenever they detect a data breach, sometimes as soon as a couple of hours or 1 or 2 days at most, so that their customers can also take the necessary measures into protecting whatever information might have been disclosed about them. Data can be shared. And keep in mind that when you choose to give your data to somebody else for storage, for processing, for a business relationship, if they have a data breach, then you're going to have a data breach, right? The ultimate accountability, even though they should be protecting their data, the ultimate fallout of that data breach is still going to affect you. Now, with that being said, we still have some legal agreements here that can make life a bit easier whenever we need to share data among multiple companies. Starting with an SLA, Service Level Agreement, which is the most common document that outlines how a specific service should be delivered. If the metrics are defined in there, then any potential fines or any potential penalties for not complying with those metrics should also be written in that SLA. Interconnecting security agreements are relevant for federal government and whoever chooses that federal government to work with. So if there's a relationship between a federal entity and some commercial entity out there, then an interconnection security agreement is going to be signed. A non-disclosure agreement, an NDA, is a document that helps protect sensitive information. Whenever we're sharing that information with someone, if they sign an NDA, then they're not authorized to further disseminate it. We are legally protected. Finally, we also have other types of agreements. In general, these are agreements that are strictly connected to a specific field, such as medical, finance, or in general, some agreements that pertain to personally identifiable information. So GDPR, HIPAA, they all have such agreements in which once you sign them, you basically promise to comply with the regulations that those standards entail. From a technical perspective, protection of data can happen at 3 levels. First of all, we have data at rest, that is when data is stored, and this is where we apply techniques for protecting data such as encryption, and don't forget about access control, who has access to the place where the data is stored. Data in transit is about means for protecting data as it is being communicated from one system to another. We can enable link encryption, we can enable encrypted tunnels in here. It doesn't matter if it's IPsec or TLS or whatever tunnel you might have in there. Just make sure that the medium that we're using to transfer that data cannot be sniffed, intercepted, or altered in any way. And finally, we have data in use. That is when data is actually loaded in a computer's memory. Whenever you have to use that data, regardless of how sensitive it is or how well you've chosen to protect it at rest or in transit, whenever that data reaches the memory of your computer and needs to be usable, that's when the data is visible, it's in clear text, it's unencrypted, because that's the only way in which that data can actually be made useful, which opens up to theoretical risks of malware infecting the computer that is processing sensitive data, which might lead to the disclosure of that data. And over time, many solutions have been introduced, especially by hardware vendors, to help mitigate these risks. One of them is called Intel's Software Guard extensions, which allow you to actually work with encrypted data in memory. For companies or systems that process sensitive data, data exfiltration or protecting against data exfiltration becomes a very important topic. Data exfiltration is any unauthorized copy or unauthorized transfer of that information outside of its approved environment, so outside of the company, for example. Systems that protect us against data exfiltrations are called DLPs, data loss prevention, or sometimes called data leak preventions. Now, these are pretty complicated systems. They are first and foremost reliant on data classification. So you need to have a very thorough understanding and classification in each and every file that lives inside of your company, so that the DLP solution can know whenever they detect that file being attached to an email, being sent over instant messaging, being sent over an encrypted tunnel perhaps, they would be able to apply a specific policy according to the contents of that file. In general, DLP solutions can apply a multitude of actions whenever they detect a specific type of information in an exfiltration attempt, and those actions range from a simple alert that is generated to reach the admin's workstation. We can also block the access to that file for that specific user that attempted the exfiltration. We can also quarantine the file. That is, whenever we sense that somebody has tried to exfiltrate that data, we are basically isolating that data for everybody else so that nobody else is going to attempt the same action. Now, this of course warrants some investigation and intervention from the admin side. And finally, tombstone means replacing that file with a simple notice or a generic file that says that this attachment here was removed because it violated the company DLP policy. Finally, the last topic that we're going to be discussing today is a topic about the technologies involved in ensuring or enhancing the privacy of our data. And it all starts with the way you choose to collect that data and how much of it you're collecting it and for how long are you storing it. And this is called data minimization. That is, don't collect more data than it's actually required for the intended purpose, and don't store it for longer than it would be required for that purpose. Also, if you did collect more data than intended, make sure that you sanitize it first before you store it long term. So you remove all the personally identifiable information from it, or you remove any fields that could potentially tempt an attacker in a data breach. An example of minimization is also called de-identification. That is, removing all the sensitive information from that data, especially once that information is no longer needed for long-term storage. So as an example here, you might be obtaining a customer's credit card in order to perform a transaction, but are you going to store that credit card information long term? No, in most cases, you're only going to store the last 4 digits so that the customer is going to be able to see which card they used on an invoice, perhaps that they might be generating a month from now. That's a type of de-identification. It's also useful whenever you're communicating sensitive information between companies and between business partners. Anonymization is a process where you're simply removing all the identifiable information so that nothing can be used or extracted from that data set in order to identify a person. Pseudo-anonymization is some sort of a gray area where you're still removing that identifiable information, but then we're storing it someplace else. So with sufficient permissions and sufficient correlation effort, we could combine those two data sources and obtain the original data source. And while pseudo-anonymization is reversible, data masking is probably the simplest method out there, which is completely irreversible. So we're simply replacing characters and data sets and data structures from that sensitive set of information with generic characters such as stars and hash signs. You probably saw this whenever you're looking at a previous transaction and you're looking at those credit card numbers that were used to perform it. Strictly for database storage, this applies to data masking as well. We have tokenization. Tokenization is about replacing the sensitive field with a token. It's a random token. Now, that token becomes some sort of a key or a password that can be correlated with the original data set that now is stored on a separate database. Now, we might provide access or more generic access to the tokenized database, but we're not going to provide access except for after a very thorough authentication to the actual database of tokens. So whoever needs access just to the summary of the information or just to the an overview of that data, we can provide them with a view of the database that only displays those random tokens. But in case we need to actually rebuild the original data, perhaps for a forensic investigation, let's say sometime in the future, we can also unlock that token database and then correlate it back with the original database in order to build the original data set. Aggregation or banding, it's another practice that can be used for statistical information. So let's say you don't want to store the exact age of a person in a database, but you would store it as a range. So that person is somewhere in between 20 and 30 years, or 30 and 40 years. Now that information can still be used to perform some statistical analysis sometimes in the future, but it stops being personally identifiable. Hashing and salting are other methods for hiding information. A hash, it's a one-way function that can generate a fixed length string, unique string, out of any data input that is being provided. Now, the only thing you can do with a hash, since it's irreversible, you cannot get the original data set out of it, is to figure out if two data sets produce the same hash. So you could potentially still hide that information, but be able to identify if two people have the same age or they live at the same address without actually viewing that information or having access to that information. This is also used with passwords. Whenever we have to store passwords, we should never ever store them in clear text. What we are storing is actually a hash of that password, so that when we're checking for the username and the password of a user that tries to log in, we are hashing the password that the user sends us, and then we're comparing those two hashes. This is very useful because in case of a data breach, the attacker is only going to obtain the hashes, and in general, it's not going to be possible to extract the original passwords out of those hashes. And this is where the process of salting actually improves this inability of the attacker to crack those passwords. Salting makes password cracking a lot more difficult, next to impossible, whenever those passwords are stored as hashes. Basically, the salting process means making each hash unique, thus making the use of pre-computed table hashes, also known as the rainbow tables, from being used in order for an attacker to be able to determine which original string was used to generate that specific hash. Finally, the de-identification attacks are more of a theoretical concept, but whenever you're choosing different methods for hiding that data or for splitting that data and storing it in separate places, you have to assume at least the risk of some smart attacker being able to correlate that partial information and take it from multiple sources, perhaps even combine it with publicly available open source intelligence over the internet, and try to determine some things that were meant to be hidden. So this is called a de-identification attack, and an attempt to correlate seemingly incomplete data sets in order to determine something more about that data that normally would not be public knowledge. So I hope you had fun with data, as much fun as someone could have with data, of course, but hopefully this was interesting and informative, and if it was, like and subscribe, share a comment with me, support the channel if you can, and see you on the next video.